Thank you very much for having me, Frank and Memverge. And I kind of want to start where the question that the gentleman just asked left off, which is talking about kind of in this new, brave new world of agentic memory, if you will, what kind of data structure should we be thinking about? And I'm from Qdrant. We're a vector store engine. So I'm assuming everyone in this room is familiar with vector stores. If you're not, go ahead and raise your hand. I can give a quick intro. Okay, cool. Okay. So vectors are basically, I'll give a quick overview. Vectors are basically the idea of being able to go beyond just text search. So, for example, let's say you have a PDF, let's say you have a video, let's say you have an image. You want to be able to search through that corpus. So, let's say you have a video, you want to be able to search it and say, tell me every time the white car went by. Obviously, keyword search can't do that. Same thing for a PDF if you wanted to search for, tell me every time in this transcript that someone was upset. You could try to search for specific words, but that might miss context. The idea is taking unstructured data and being able to search through it the same way you would be able to with structured data. The benefit of this is, first, you're searching through vectors, which is going to be much more efficient than searching through the actual documents. And second, you can do some really cool stuff with unstructured data where we can do similarity search for different kinds of data. So I can say, for example, fun date night outfit and get relevant results for a fun date night outfit, even though I haven't tagged any of the products in my catalog as fun date night outfits. And when I think about memory specifically, I think you need three different pieces of your memory. You're going to need that vector search, which is the part that I just talked about for that semantic recall. You're also going to need graphs to be able to capture the relationships in your data. And then finally, you need some kind of relational database for those transactions, like he just mentioned. So the key takeaway for me is if your memory system is just relying on one of those, then you probably have some gaps there because you really do need all three in order to hit everything. Otherwise, you kind of just have logs. So I want to talk today about 6 different use cases that I've seen from people who are actually using Qdrant and talk about some real implementation patterns that they have. Quickly, let me just talk about Qdrant. So the idea, once again, is in 2026, your agent doesn't just want to do full text search. It wants to be able to search through a GitHub repo and say, tell me how to connect the Fast API connector or something like that without having to do an exact keyword search. It wants to be able to say, what did I do last week, and actually pull up relevant results for what you did last week. So that's where we move beyond that keyword search. If someone types in car, you need to also return automobile results, right? We know that now. So, wrong button. So this is the Venn diagram here of full text search and vector search. But you can imagine in your head there's also a Venn diagram here for graph search and maybe transactional search, where you're putting these all together in order to create that real-time memory. And real-time is where we can start because part of the problem that we have with keyword search is what I have here up here, which is this idea, if you search for something like car, if you just do keyword search, it's not going to return automobile. You also have this issue of the semantic gaps. So if I type in machine learning, it should also return artificial intelligence. And finally, multilingual and typos, right? If someone just types something in wrong, or if it's a different language, you still want it to work. The real-time part comes in because what we found was a lot of customers were doing batch uploads. And for memory, that's not going to cut it. Why? If I'm interacting with a system and I tell it, hey, I like steak, and then in my next turn, I say, recommend me dinner options, and we're only doing uploads nightly, that's not going to work because the agent isn't going to have updated. It's not going to know what's going on. So the very first thing that we think about is When you create your embeddings or when the user generates any kind of text, we want to update that in real time. And that's where Memverge is using Qdrant under the hood to power not only semantic cache, but also that memory layer for the semantic part. So in terms of, I'll skip through that one. So in terms of the real-time upsert, what makes it special is what I have up here, which is the Qdrant architecture. And you're starting off first with just your cluster. Then in your cluster, you have collections. And then in your collection, you have points. And those points can have metadata. So one of the metadata fields you could have is, for example, timestamp. Now, once you have the timestamp with that metadata, what you can do is, like he mentioned, if someone says, I like pizza, but it was in 2023, and then someone says, I don't like pizza, but it was in 2025, you can supersede their pizza preference, if you will, by the most recent entry. So those real-time inserts are still going to work because you can basically have that versioning via the timestamp. I'm going to skip over this one as well. So the workflow is important because when you think about your agents, this is going to be happening hundreds, maybe even thousands of times at once. And any kind of latency gap that you see in this process is going to amplify over and over again. So if you have, for example, a 50 millisecond gap, you might think that that's not a big deal. But when you start talking about 20, 25 agents working simultaneously, making simultaneous calls, all of a sudden 50 milliseconds can really add up and really show latency on the user end. So what you can do to mitigate that is use tools like quantization. So quantization is going to allow you to basically turn your vectors into these really small, smushed down vectors. It's kind of like normalization. So you can imagine if you had a column in your data set that was something like miles per hour, top miles per hour for a car. For some use cases, you might actually care about the granularity of what that miles per hour is. It's 222. For most use cases, it's not really going to matter. Most people who are buying a car don't care what the top speed is. All you need to know is maybe it's above 100 or below 100. All of a sudden, you can take that payload, which before was floats or maybe even integers, and just turn it into a 0 or 1, because you're just saying, is this above 100 or is this below 100? And by using techniques like that on the payloads where you don't need that really specific data, all of a sudden you can take this process, which is the typical search process, and speed it up. So when you're talking about techniques that you can use to speed things up, what we see is a lot of people are using binary quantization. There's also different kinds of quantization. There's scalar, there's product. So you could, for example, have a really fast, or let's go to gas miles per hour. You could have a gas guzzlers, an efficient, and balanced. Instead of just having that binary 0, 1, you could have different categories. So that's something that you can use in terms of speeding up your vector search workflow. In terms of why Qdrant specifically, because there are different options out there, the things that we pride ourselves on are going to be hybrid search. So that's being able to actually use the keyword search with the vector search. So if you, for example, wanted to search Harry Potter and find out every time Hermione was mentioned, but you also wanted to know every time Hermione was upset at Ron, that would be a great use of hybrid search, because you can not only find every mention of Hermione, but you can do the semantic search to see, was she actually upset in this mention? Scalable. So we really like fast and scale. We have clients that are using us for billions of vectors. You can still get that sub-second latency, even when you're scaling. Deployment flexibility, so you can use Qdrant on Docker, you can use it locally, you can use it in the cloud, private deployments, Kubernetes, etc. And filters. So filters are huge for agents because they allow you to now, for example, as I mentioned earlier, you could have a filter on the timestamp. And that's going to make your search a lot more powerful, because if I said, hey, can you tell me what we talked about last week? The agent can actually filter down the search based on the timestamp to make sure that they're returning relevant results that aren't from yesterday, but also aren't from a year ago. This is vector search fundamentals. I'm going to skip through that. I'm also going to skip through this one, but I will mention this, which is HNS-W is the engine behind Qdrant. So as we mentioned earlier, the reason why you need those multiple data types is because HNS-W is really going to excel at finding the semantic relationships, the different meaning, the different context between your documents. But we have a client, for example, who had a alerting system where they wanted to be able to say, wake me up at 8 a.m. That's something that they're doing in a more traditional transactional database because it doesn't really include any kind of semantic meaning or kind of memory, right? That's just a hard wake me up at 8 a.m. So the way that you can think about Qdrant is we're a foundational building block specifically for that search and retrieval piece of your memory. But it shouldn't be the only piece of the memory stack, and that's why you can use stuff like MemMachine from MemVerge, which is actually going to put that all together for you. It's going to have semantic cache out of the box. Everything's already configured for you. But what MemMachine is doing is not only with, what MemVerge is doing is not only with MemMachine, but they also have other offerings where one of the problems that you'll come across with this HNS-W is it's going to eat up your RAM because you want to keep all of your files on RAM so that you can search them quickly. MemMachine is basically going to be able to offload your data, but depending on your different patterns, depending on the different proprietary stuff that they have, so that it knows whether to hit hot or cold storage depending on the user's query. So in that way, you can really optimize your search patterns because if you know, for example, they're asking what's the weather in New York, well, that's got to be a fresh query. If they're asking what's the capital of New York, we don't need that fresh, right? Because obviously we can store that, pull it up from cache. So this is the data model. I mentioned that already. So multimodality, this is a pretty big one, right? Because what we're seeing is there's a lot of people that now want to build these agents that not only work with text, but work with audio, work with video, work with images, PDF, etc. One of the cool things you can do with Qdrant is you can actually separate out the modalities of your data. So let's say I have a video that's a video of or a movie might be a good example. I'm a movie studio. I have holidays coming up. I want to put together an ad of a holiday movie. What you could do is you could search through your video catalog based on the transcript, which would be the text. You could search through your video catalog based on images. So you could upload an image of, let's say, Brad Pitt and say, show me every scene where Brad Pitt's in it. Or you could also search through it based on sound. So you could say you have a clip of a bird chirping, and you could say, show me every scene where there's a sound similar to this. And this is really nice, obviously, for manufacturing, security, monitoring, observability, etc., where you can have a video pointed at something and basically have an automatic anomaly detection system where the way it works is we're going to look at the images from the video and compare them to the baseline of whatever we think it should be. So we worked with a coffee company, for example, for anomaly detection, where in their plant, they would take pictures of batches of coffee beans. And since we knew what good coffee beans looked like, we could catch issues in the production process faster, because if we saw a picture of a batch and we were like, ooh, the vectors of this image don't match the vectors of a baseline image, we could have someone actually go out and investigate, right? And the same thing would apply for maybe a parking lot. If you know at 3 a.m. the parking lot should have 0 cars, all of a sudden the parking lot has 7 cars, make sure you send a security guard out there to check that it's a legitimate reason for all the cars being out there. So when you think about semantic similarity, you can also think about semantic dissimilarity, which is super useful for agents, for example, who are monitoring things like logs, video, unstructured data in general. When something weird comes in, they can raise a flag and say, hey, this document doesn't match the rest of them. Let's go ahead and check that out. Payload indexes are going to be those filters. So I mentioned this, but I think it's worth repeating a bit. you can add metadata to your semantic data. So vectors are just numbers. Humans don't know what vectors are. Humans do know what filters are, though, right? So I might say, going back to that fun date night outfit, but I want it to be size large and I want it to be under $100. So you can mix in the semantic filters, or not semantic filters, semantic search with those hard metadata filters. Qdrant also supports full text search. So this is going to be super useful because sometimes you do want that full text search. Let's say you're searching for SKU for a product shopping app, or let's say you're searching for a proper noun, like a person's name. You don't want any kind of semantic search there. You want to just return all the documents that you actually looked for. These are some of our different APIs that you can use, and the one that I think I want to highlight here is the recommendation API, which you can use basically to create recommendations on the fly. So that's pretty useful for any kind of agent that needs to, for example, make recommendations to users when they're checking out of their cart and say, oh, do you also want these items? We can just recommend similar items. It's also good for replacements. So if you're an online shopping app and you ordered a gallon of milk, the person can know, hey, instead of getting a gallon, I can get a half gallon, or whatever semantically similar to the thing that's out of stock. I'm going to skip over the search API and scroll API. I do want to talk about this one, though, which is this idea of you can have positive and negative recommendations. So when you're building your agent, when a user says thumbs up or thumbs down, that's what's happening here. So it's not just that they like something or that they dislike something. It's they like food that is spicy, but they don't like food that has meat. So you can combine those two things to come together and say, okay, what are spicy vegetarian dishes? As opposed to just giving them vegetarian or just giving them spicy. The Discovery API is a similar concept. I'll skip over that. Okay, so quickly want to get into some kind of nitty gritty RAM versus disk trade-off stuff. So one of the benefits of using something like MemVerge or MemMachine is offloading some of that architectural thinking or architectural load onto someone else, basically. They're going to handle it for you, right? But to understand a little bit more about how it works under the hood, basically, imagine you have to request 1,000 requests. Sorry, you have to maintain 1,000 requests per second. So we had a company we were working with where they needed 1,000 requests per second, and they wanted to quantize some vectors in RAMs. But if you have that many requests and that much data, trying to do it all at once is going to be a huge latency burden. So what you can do is you can use offloading to disk. And you can basically offload some of those vectors onto disk to be able to speed up search. You don't want to offload all of the vectors because then your search quality is going to degrade. But you can speed up your search by playing around with what you're keeping on RAM and what you're keeping on disk. You can keep, for example, the full vectors on disk and just keep the indexes on RAM. So, for example, you can mess around with those different patterns, and in that way, you can have your hot data automatically brought into RAM whenever you need it. So that's like more of a nitty-gritty thing, but if you're using Qdrant or if you're using MemVerge, you're going to already take advantage of that. But if you're rolling your own, one of the things you can do is think about that distribution between disk and RAM, because RAM is obviously going to be faster, better search, but it's going to take up more resources. So you have to think a little bit about how you're handling that. And then finally, or two more things. One thing I want to leave you with is Qdrant Edge just released in beta. And that's going to allow you to now run Qdrant on devices. That's huge for agents because now, imagine your tech support for a plumbing company, or I guess maybe not plumbing, for an internet company, and you have to go into a factory somewhere to fix a router. You don't have internet access, and you need to ask a question, should I cut the blue wire or the red wire? Well, if your device only works with the internet, it's going to be a non-starter. So what you can have is this edge device. You still have a cloud database that's going to say, cut the red wire. But when the technician has gone off into the field and doesn't have access to the internet, they can still take a picture, a video, ask a text question, which wire should I cut? And it's going to give them the answer. Now, the cool thing about Edge is, let's say they cut the red wire and it blows up. They can actually add a report that says, hey, I went out to unit 37, I cut the red wire, and it actually blew up. Don't cut the red wire when you're on an odd labeled unit. And when that device connects back to the internet, it's going to update the database so that when the next technician goes out and they're in the same situation and they ask, which wire should I cut? It's going to say, don't cut the red wire. Jim tried that and it didn't work, right? So with those real-time upserts I'm coming back to, even if the technician left right after the data was uploaded, they would still get that new data, right? You wouldn't have to worry about batch uploads or when the data is getting uploaded. And then finally, I want to talk about coming back full circle. Just a pattern you want to think about when you're doing your writes is make sure that you're writing to two places at once. Don't just write to your vector store. So for example, write to your transactional database and write to your vector store as well. And in that way, you don't just have one record of truth and you can call from both places at once. So when you're thinking about your vector store, this is quantization. I'm going to skip through that. Sorry. When you're thinking about your vector store, basically what you want to think about is this idea of specificity, coverage, and conciseness. That's going to be the building block that the vector store powers. But the vector store cannot be the only part of your system. So that's my presentation on agents. I'll be sending this. Oh, one more quick one I'll just mention is semantic caching, which Memverge also is going to do via Qdrant. Semantic caching is really nice because you can ask a query, and if the query is semantically similar to a query that's been asked in the past, instead of hitting your LLM, you can just hit your cache. And this is actually becoming a bigger problem for people than any kind of scaling, any kind of search, any kind of retrieval, because people are wasting huge amounts of money by hitting the LLM with questions that they already have the data for. So making sure that you have a semantic cache that's timely, but not too timely, that also knows what kind of questions are being asked. So weather in New York 30 minutes ago, let's not cache that. Capital of New York, let's cache that because some data is going to change, some data is not going to change. So making sure that you set up your semantic cache effectively is going to be another big one. So thank you very much. My name is Thierry Damiba, and I'm from Qdrant. If you have any questions, let me know.